So this is one of the last sections for Unit 1. And this is really an important lesson because everything we do here is going to apply pretty much Math 1, 2, and 3. So really wanting to get this down. If you have questions, you got to ask them. Especially if we get to classwork, when we get there, you got to ask questions. So I think we know some of this already. We're just rearranging equations. Usually when we rearrange an equation, we're solving for a variable. Okay? But in this case, look, we have two variables in the equation. So I know in my answer, there's going to be a variable that's still in there. Okay? I'm not going to be able to solve and like have y is equal to 5. Right? We're gonna solve these for whatever we need to solve for. Okay? So the way that we isolate and get y is equal to see what y, when we solve for y, what it's equal to, we're going to use the inverse operation to isolate the variable. So it's usually y or alternate if we ask for, h or x or z. You're just going to isolate so it's z is equal to something else. Okay, so looking at this, if you have square root, you square it. If you have multiplication, you divide. If you have addition, then you do subtraction. Okay? And the only thing we have to remember is you must do the same operation to both sides. Then you're fine. You haven't done anything wrong here. So if I had 2x is equal to 4, what's going on between 2 and x? What's going on here? Between this 2 and this x. When they're right next to each other, what's happening? Multiplication. When they're right next to each other, it's multiplication. So how do I break a multiplication chain? I do the opposite. Divide. I divide it by 2 on both sides. That breaks the chain because what happens to 2 over 2? That's equal to 1. We can cancel it. X is equal to 4 divided by 2. X is 2. Yeah?
I thought the thing was just to try to get the variable by itself.
Yeah, that's what we did down here. We solved it. So it's the same process. In this first example I gave you here, we only have one variable. In the other ones, we're going to end up with a variable left over. Okay, so let's look at this first one here. We're solving for y. It's 2 times y, so my chain here is multiplication. So what should I do instead of multiplying? Divide. I'm going to divide by whatever I want to get rid of. If this was negative 2, I'd divide by negative 2. But it's only 2. So then I divide by 2 here. Those cancel because this is equal to 1. So y is equal to what? What's 10 divided by 2? We can reduce this number at least. 5. 5x. This is my answer. We may not be used to having variables in our answer, but we're just rearranging things. Nothing has changed here as long as you do the inverse operation to both sides. So I'm going to, both sides, inverse operation, that will get you there, okay? So I wanted to do this example right here just as like an abstract idea. Because what are the 3 symbols you see there? Star, kind of clover, diamond, right? If you needed to solve for, let's say we need to solve for star. First off, I know that 2 and star are connected by multiplication. This whole term is connected to clover by addition. And just like peeling an onion, right? One day I'll get it. That's an ugly onion. I don't know. Just like peeling an onion, you want to work from the outside in. Outside in. So which chain is further away from the star? Clover, because it's 2 and star are right next to each other being multiplied. So I'm going to minus my clover to both sides. Okay, that's going to cancel here. 2 star then is equal to diamond minus clover. So you're just moving the objects around. You're moving the objects around so you can isolate the star. What's the last step though? Because we have 2 times star. So what should we do? 2 times star instead? Divide by 2. Everything divide by 2. I've divided the entire left side by 2, the entire right side by 2. So I'm going to end up with our star is equal to diamond minus clover, all divided by 2. And I want to do an abstract one because you see, this one is really complicated. If these were, x, y, and z, there's 3 variables in there. But all we're doing is isolating. If we want to solve for star, we isolate it by moving everything else out of the way. So it's just what star is equal to. Okay, so maybe that was helpful. If it wasn't, then that might have been helpful. Maybe it was even 10% helpful.
These questions are just going to be on the. These are the same questions going to be on the.
Yeah, very, very similar. In fact, I think that the last example is number 10 in your workbook. So that's what we're going for. Let's see when we get there though, because we still have a little bit of practice before we get to that one. So that one has a lot to it, right? The pi's in there. It's tricky. Let's look at this one. I want you to tell your neighbor, what do we need to get rid of on the left side in order to solve for x? Just tell your neighbor really quick, what do we need to get rid of? Yeah? What do you think? What do we have to get rid of in order to just have x is equal to? So x isolated. What do you think? I think we should get rid of this 12. And we should also move this y. Okay? It's all multiplied to x. So essentially we have x chained to x by multiplication, x chained to y by multiplication. So what are we going to do to get rid of both of those? Break those chains. The inverse divide. Now, I can divide by 12 and then divide by y. I know I'm going to divide on both sides, but what can I divide by to get rid of everything at once? 12y. I divide by 12y on both sides. 12 divided by 12, 1. Y divided by y, 1. So we get x is equal to 4/12. Let's go ahead and reduce that. What does that reduce to?
3.
4/12.
Oh wait, 1/3.
1/3. Divide both by 4. 4 divided by 4 is 1. 12 divided by 4 is 3. So we get x is equal to 1/3 y. All you're doing is solving for whatever variable they say to solve for by isolating it, doing the inverse of both sides. Yeah, we see this. We've kind of seen some of this before. It's like solving equations. It's just they have more variables than not. Okay, let's put a line down this one because it's a little complicated. Solve for x. What's the first thing I need to do? What you think? Let's hear it. What do you think? -5? You do it? -5 minus 5. I like to put a line sometimes if it's really complicated. We get 5x. These are going to cancel, negate out. 5 plus y. Let's get everybody up on that step there. And then, Jasmine, what's the last step?
Divide by 5.
Perfect. It's multiplication. The chain there is multiplication. So I'm going to divide by 5 on all sides here. X is equal to. Now you could leave it like this. There's one other form that you could do to make it a little more simple. What could we do to make it a little more simplified?
0.
0. That's 0.
Cancel out the 5s.
Let's do it. Now here's the deal. This is 5 plus y divided by 5. So it is essentially the same as 5 divided by 5 plus y divided by 5. Because think, if we just had to add these together, they have a common denominator. So the common denominator would be 5, and it's just 5 plus y, just like we had in the prior step. So this hasn't changed anything. But 5 over 5 is 1 plus y over 5. And that one was like one of the trickier ones there.
Wait. If you canceled out, how'd you get 5 and y over 5?
Well, I started with this 5 plus y over 5. And it's saying that 5 plus y is being divided by 5.
So both of them would be divided by 5.
Correct.
Okay.
You can always break it up like that. And if I had, plus z plus m, it really is just 5 divided by 5 plus y divided by 5 plus z divided by 5.
So on.
So when you're dealing with fractions, and think if we had to add all these fractions together, we would need a common denominator. We have it. So all of these added together over 5, they're equivalent.
And then you just solve.
Yeah. So it's it's a similar process every time. It's always just do the opposite operation of both sides. So let's see about 2 more to go here. Let's see about this one. I'm going to let you guys work on this one a little bit on your own. Remember, We want to isolate z, so I'm going to help you out a little bit. We have z in -3 by multiplication. We have z in 2y by addition. So I want you to break both those chains from the outside in. Move everything over to the right except for that z. Except for the z. This one's trickier, so hey, call me over if you need a hint on this. Let me get a pen. So we want to get z alone. So we're eventually going to divide by -3. So how about this first? So we're going to subtract 2. Let's subtract 2y. Subtract the whole term over there. I want to get z by itself. I don't really care about 1.
Subtract 2y to the
Get over. But that's the first step. So ask your neighbor if you don't know the first step. Check with your neighbor. Say, hey, I don't know the first step. Make sure that you're not just waiting for us to work it out. So this. So just simplify that. Okay, I'll do the first step because I want to go after that first chain. And the first chain I want to go after is that plus 2y. Usually we see a variable and we're like, oh, I need to divide by 2. Who thought that first off? You're like, I need to divide by 2 to deal with the y, right? No. We want to move that whole term, just get over to the right. In our answer, we're going to have this y value. So watch, -2y, -2y. So that is going to allow me to have a -3z. Still got that chain by multiplication. And then we have -3 minus 2y. Nothing happens there. We can't combine them. It didn't equal 1y. Because this is a 3, that's a -2y. You can't combine those. So if you did that wrong, put a little arrow here. Cannot combine. We need like terms. Those aren't like, so they got to be set like that. So we're almost done. We got to break this one chain. Go ahead and break it. Simplify if you can do it. I want to get more than 3 out of there. Because I won't.
Divide by -3.
-3.
So isn't it?
How about this? I'm going to divide this by -3, divide that by -3. We'll be able to simplify it better that way.
So isn't just z equals 1 minus. I mean, I don't really know.
You're so close.
Oh, 1 minus.
Negative divided by a negative, just like multiplying.
It's 0.66.
Plus
If you make it.
2.
You could say 2/3 y. You could say 0.667 y. That works. That's my answer.
Why is it plus?
Because a -2y divided by -3. Multiply and divide have those same rules. Okay, we're going to do a last problem, but how are we right now? Thumbs up, sideways, down? Good. Okay, that's pretty good. I think we do one more problem. Maybe then in the classwork we'll have 5 or 6 minutes to do a few problems. Let's go ahead and do this last problem. Now here's the deal. What do we need to solve for?
Pi.
H.
H.
H. We got to solve for H. All these are multiplied together. So we can do, let's get rid of this part first. Okay. think of that as one thing. It's all multiplied together. So I know h is connected to this by multiplication. H is connected to the 1/3 by multiplication. Now, these are all multiplied, so they can be in any order. It doesn't matter. 2 times 3, 3 times 2, doesn't matter.
Can't we do the divide by negative? No, divide by r squared or something, or n
We could do it one step at a time if you want. Let's do it. R squared.
against that.
That cancels this out. So now we have b over r squared.
And then for pi,
Good. Times pi times h.
do we say for pi or no?
Let's get rid of pi.
So we do divide by pi,
There you go.
and then we do
So I'm going to just put the pi in the bottom.
Oh, we leave it there.
Yeah, because it's really just all of it divided by pi. So, yeah, we have b over pi r squared is equal to now 1/3 h.
So then we do divide. No. Do we have to get rid of the fraction?
Yeah, let's get
So
rid of it.
times 3 times 3.
Yes.
So it's
Perfect.
It's 1 times h.
Perfect. So 1/3 times 3 is equal to 1. So we have 3b over pi r squared is equal to 1h, which I can just call h. Okay. That's as hard as it's going to get. But just remember, like with the star, clover, diamond example, it doesn't matter how many variables or shapes you have, you do the same process. Okay, this was number 10 on in your workbook, so I'll leave it up. You can go ahead and work on that and probably get through the workbook problems, or at least 2 of them, 2 or 3 of them. Okay, so let's do that. We have about 7 or 8 minutes, so let's go ahead and do that to start. All right, that's it.